Here we're given an overall reaction where you have your reactants making this product, and it tells you what the change in enthalpy standard wise is to be this value, and here you're given the activation complex formation where your reactant is going to make a transition state, and this is how much energy required to achieve that. So this here where you see EA, it represents the activation energy. Then how can we propose a structure that is going to end up becoming this? First is that we know that we are going from circle triangle to now circle pentagon, and so to accomplish this we need to break our O triangle bond, and this here is going to be having this to have a partial positive partial negative charge, and this is going to be forming a new bond with what the triangle will give new bond with a square or rectangle, and this rectangle here will be breaking a bond with the what in this case the pentagon. And once this is accomplished, know that this is going to have a partial positive charge and this is going to have a partial negative charge, and this here is going to be forming a new bond with the O. And so this here is a proposed pathway that is going to hopefully end up becoming this particular product. And so the question now is, what is the potential energy diagram? And so to accomplish this, we put our y-axis, and this here is going to represent our energy or potential energy, and this here is going to be our x-axis, which represents our reaction progress. Now in here we see that the value for the change in standard enthalpy to be a negative value, which is an exothermic process. Therefore we should have our energy for the reactant to be more than or greater than that of the product. Therefore we are going to have weaker bonds here and stronger bonds being formed here. Now this here, the gap is going to be the enthalpy change in this case because it is standard. It tells that this is an exothermic reaction, energy is going to be released, and the next part is from the reactant to the maximum hill that it has to overcome. That hill here, the energy required is called the activation energy, and so this here is going to be around 100 kilojoules that is going to be required to achieve the transition state, or we'll call it the activation complex. And this is exactly what we just drew right over here, and then this is going to arrive at the formation of our product, because now this energy has been overcome due to the right collision process and the right amount of energy, right effective collision to reach our transition state and produce product. Now there are other things that may influence this particular pathway. For example, catalyst, it can change the activation energy pathway by looking for other pathway to reduce the activation energy and arrive at your product. It can be one or many pathways. So pretty cool stuff when it comes to questions like this.